where it is really meaningful. We also have Poochie. A few of you might see Poochie is the quadruped robot dog, and Poochie has been actually deployed at 3 customers. Works very well with respect to looking at inspections and safety. So these assets on the stage are a manifestation of what has worked and how we have been able to transform these into real implementations. All this will not be just on a PPT where we'll actually do this live today. Finally, once the blueprints are applied, we'll eventually go to the test demo space there. We'll actually do some tests. But let me give you, I spoke about the last 10 years. There are two different streams, right? If you look at it, at one end, we have this AI journey going on, and at the other end, the industrial robotics journey. When they started off, there is traditional AI and there is industrial robotics. Both of them were largely deterministic. What I mean by deterministic is both of them were rule driven, right? There were machine learning based rules, there were machine learning based algorithms, but there are sequence, they are deterministic, right? They were trained on a historical data. Industrial robotics on the other hand also did a repetitive action which was governed and deterministic. Then came in generative AI, became a catalyst for a lot of transformation. And within generative AI, what it did, it actually brought a lot of augmentation. You are able to augment the human work and simplify the day in a life of a persona with something new, and that's what generative AI did to the AI world. On the robotics side, we had collaborative robots where the augmentation was done by a cobot with a human plus robot operating model. Then came in agentic AI, and then came in agentic AI, and agentic AI actually brought in the orchestration and action part, stitched across multiple agents, and in case of robotics, stitched across multiple robotic arms versus 2 physical assets. It could be anything. But why I am showing this chart is, if you look at it, the top line and the bottom line, they're actually converging, and this convergence is leading to what we call physical AI. It's where the digital AI gets bridged to the physical asset, and the era of software-defined physical intelligence is here. But the question is, why now, and why India? I want to spend a little time here. If you look at global aspects and what's happening in the West, and not just West, in general, globally, there is an aspect of, let's take a look at supply chains. You are actually, in West and globally, majority of the other places, you are actually looking at supply chains and using AI to actually address the brittleness of the supply chain, resiliency, fear and supplier ecosystem integration, bringing in AI there to address geopolitical risks, tariff impacts, all of that. In India, the situation is a different. It's a unique challenge and a unique opportunity, and it's more about looking at how you can build some sovereign capability, how you can introduce newer nodes on your supply chain, how you can do poly sourcing. Take about an example of a legacy factory floor, right? In the West, you are actually bringing AI to basically do transformation with legacy OT systems. You are trying to optimize on top of that. India has a very unique opportunity and a significant advantage now to leapfrog from where they were to actually going into AI native factories and AI native industrial corridors. That's why it's a very unique opportunity. Then we talk about capex investments in driving this automation. The consumption model in country like India, we have a very significant opportunity to look at robotics as a service, fractional robotics, and last but not the least, while automation in the West is being looked at more from a aspect of addressing skill gap issues and workforce issues, India doesn't have that big of a problem. It's more about amplifying and augmenting the workforce to do more with less. So given all these different aspects of comparison, there's an aspect of bringing the digital version, which is the bridge between what we have to bringing the digital version to the physical assets, and address two big challenges, right, which gets mentioned. One is the last mile access to basic services, whether it is public services, education, healthcare, and address the problem of missing middlemen intermediary. And that is possible with physical AI through last mile workers, last mile technology, last mile process to achieve and address both these challenges. Great. So now we have spoken about context of physical AI, spoken about technology evolution, spoken about region and ones for India. There is an aspect of manifestation of each one of these, right? So you have the digital to physical bridge gets manifested in multiple forms. We have humanoid, you are seeing one on stage today here. You have quadruped, you are seeing there. You can have a combination of drone and quadruped for one of our customers. We did an orchestration of a drone based imagery with a quadruped based imagery to derive something very meaningful. Then there is AMRs and AGVs, there is autonomous vehicles, of course. There could be cobots. There are multiple manifestations, right? But here are some of the use cases that have come to life. In case of humanoids, we're actually starting off doing pilots for multiple customers in terms of actually utilizing their capabilities of human-like interaction, their dexterous hands to be able to pick up a payload of let's say 3 to 7 pounds, picking, knitting, sorting kind of things. The biggest benefit is their availability, 24/7 availability. Right? Same thing if you look at autonomous vehicles. Not talk much about it, but V2X integration is becoming mature by the day. And last but not the least, quadruped. Quadruped actually the deployments have gone far more mature into customer ecosystems. Let me show you actually one example of this art of possible things that come into life. Right? So here is an example of a deployment that we did for one of the agri-tech major customers. And in the context of the customer, it was actually they have a large warehouse with processed food facilities. Scenarios like oil spills, gas leaks, ammonia vapors, these are all very common pain points in this kind of a situation. So we came in, we looked at the entire stack, right from infrastructure all the way to intelligence. We selected the device which will actually replace the manual process of inspection. You know what? In this particular case, every inspection, an inspection was done every 4 hours, and every inspection took more than 90 minutes. Um, and because of the hazardous situations, going in and doing those inspection also was very troublesome. So when we came in, we actually brought in selection of a right asset to basically do the inspection. Then we actually looked at elements of LiDAR sensing, pre-processing the data, mapping it on the GPUs. We have the NVIDIA stack there, which resides on the quadruped. Then from there, we actually looked at aspects of building the model, deploying the model, and then eventually continuously making it learn to define the So the end-to-end view helped us drive the whole safety incidents by about 90% and operational downtime by about 30%. Now this is not just an innovation side project. This is actually live in 3 different sites of globe. One in China with 30, a fleet of 30 quadrupeds are actually working live. Poland is live with about 7, and then there is Latin, which is ongoing. This is actually a progress of getting inspection and service in action. All that is what the initial context about physical AI. What we will do from now is take some of these use cases which we just spoke about in their own little small way of identifying what we can solve in the next 75 minutes, and to be able to help you walk through what's going to happen in the next 75 minutes in the logistical part of how we are going to do it. I would like to invite PLN and Pratik.
Thank you, Naresh. Good morning, everyone. My name is Laksh Parthasarthi. The room is completely packed, but still there are some optimization we might have to do. If you see in each table, there are 2 different types of assets, which is either but it could be different. Some of them have a AGV and a quadruped, some have a robotic arm. And if team of 2, if there are more people than that, we'll make a team of 3 max. But if there are some tables at back empty, there are somewhere places if you want to move around, you can do that if you are interested in a particular type of device. And for each of these devices, we have mentors. I will just call out if you're, for example, if this is basically a puppy pie, this device that looks like a quadruped is called a puppy pie. All the puppy pie mentors, can you raise your hand? So any issues during the while we have a manual, we will go through to get together. But if there are issues, they will be walking around and addressing it. Mentor pie, mentors, mentor pie mentors there. Okay. Yeah. Arm pie, they are there. The robotic arms are on the back side in case if anybody wants to work on a static robotic arm, they might have to move to the back. Right. So again, this seating is very similar to the, but I think while we had kept 2 seats empty, but I think it's all full. The plan is to spend the next 50-60 minutes, follow the handbook. We'll show you a quick preview of how do we log into the what we call as a TCS estate. That's essentially the platform that helps us to implement a blueprint into these hardware devices, where we don't need to code anything. So it's not that we have kept it coded, but it's a workflow based system where you can plug and play models. You can do a little bit of configuration, little bit of tuning, but essentially it's a no code based program where you will actually see implementing certain things in the physical asset. And at the end of the day, we will go and test it. There are testing fits. For example, for the AGV, that's the testing fit. We will go one by one, and whatever you implement will be tested there. For the quadruped or puppy pie, this is the testing area. We will test it here. The robotic arm doesn't need to move. They're already stationary on the table. So wherever we build, we will test it out. Right. With that, I'll call Pradeep to give a quick glimpse of the tool, the workflow.
Thank you. Okay, so you'll have to first log in to.
Monitor that too. And if some of you need to move around and find tool for yourself, that's also fine, right? Or you can start logging in and follow this train. So each device, two people, one device, one computer. That's essentially the concept. You want to work on an AGV site? Yeah. Is there a AGV table free? Which one are you interested in using? This one or this one? Have we decided yet? There's one AGV there. Move on. You can move that. Huh? One AGV is the back also. You can go there as well. Go ahead.
Okay, so this is the platform AI orchestrator that you will use today. So before you reach here, there are a couple of steps which is written in your manuals, and also the mentors will help you with that. You first need to log into a virtual desktop, and from the virtual desktop you need to enter the login portal. Once you log in, you will be able to come to the home page. Now, at the top, this is a minute on what this is really. So, this AI orchestrator is actually, you can say, a collection of catalog of AI resources that you will need in deploying real-world AI applications. You have a model catalog, which of course you will not need today. But this is something, an enterprise when it wants to deploy AI applications will require a lot of resources. Like you will need IoT connectivity, you will need data pipelines, you will need models. So all those things are baked catalog of templates. So you can, one way to think of it is catalog of templates, which let you select certain templates, then deploy them. So today you will be primarily using a resource called the physical AI, right? So based on the devices that you have, what we have done is we have created a certain collection of template which you will use. Hello, yeah. So based on the device that you have, what we have done is we have created a set of templates and scenarios which are inbuilt. And what is happening behind the scene is that it's taking those catalogs and it is deploying, including the workflows, which will be deployed and connected to your individual devices. You will have to do some configurations and publishing and etc., which the mentors are going to tell you. So this is going to make it easy to deploy complex, and as it was earlier said, it is kind of a low code, low configuration thing. So with this, I am going to hand it over to the mentors to guide you one by one. First, logging into your virtual desktops, and from virtual desktops into this, you will also do some editing of workflows and publishing them and making your robots work. So thank you.
Thanks everyone. Let the games begin. I want all the mentors to come at their respective tables so that you can actually get started. And let's make it interactive. It's okay to make mistakes. We are here to fix one by one, but idea is to basically get to a point where we can get the physical asset moving and actually bring the physical AI blueprints to life.
Three, four, and five is offline. Everything offline. लेके हो गया तीन चार और पाँच अगर
Hello. Usually on events I go how we share pictures.
स्विच करो एक बार, स्विच करके हटा के रखो टेबल पे सब काम चल रहा है, टेबल से
कैमरामैन
क्योंकि हम इंडिविजुअल टेबल्स पे सीख रहे हैं
वो भी क्या करे, अब अंदर खड़े हैं तो कुछ दिखेगा ही नहीं। कैमरे को भी थोड़ी
नेटवर्क दे आर कंट्रोलिंग दिस
He's not a, he's our guy. Network को बंद करा है। network को बंद करा है।
नेटवर्क इज वाईफाई है देयर
वो फिर से डिस्कनेक्ट हो रहा है। इसको बोलो ना इधर
वाईफाई कोई तो बीच में छोड़ रहा है
Check now if the Wi-Fi signal is there. I change also the just type in the chat what was the
AI class
ऊंची हो बढ़ते हुए करना है एक कदम चलने लग जाएगा और ये जो ह्यूमन होता है ना ह्यूमन सिस्टम
नेटवर्क डाउन हो गया एक मतलब सेंटर में एक जन कोई खड़ा रहा उसको चेक करेगा सो दैट दे विल बी एबल सेंटर में खड़ा नहीं लाइव स्ट्रीमिंग हो रहा है तो खड़ा मत करते
Yeah, if you show any other color, it won't try. So that's been kind tuned to this. Backend models can be tuned to this.
वाईफाई ये सब चालू है
So we have covered the whole check this. You have to talk with our sound coordinator.
Blank shots.
हमें अलाउ
Actually, every device is on AGV पे AGV के लिए वाईफाई
बाकी एक के साथ अभी एक के साथ इसका हॉटस्पॉट है, इसका शायद हॉटस्पॉट नहीं है।
यहाँ से टेस्ट नहीं कर सकते।
कॉन्फ़िगर किए थे ना आपको? इसका बस
ये नीलाद्री
कॉपी है इसके पास है वाईफाई में।
देखो मैंने वाईफाई दिया होगा 1 2 3 7 10
तुमने दिया है अपनी लिस्ट नहीं बताया इसका ऑफर
नहीं गड़बड़ बट आई नो
बोलो
विच आर द वाईफाई
मेरा नाम क्या है?
आपका वाईफाई
मेरा 10 है।
that is connected AI1 AI2
connected
AI1 AI2 AI5 AI7 AI10 and AI9 8
इसके पास
जो है इधर 19 है ये।
ये 8 जॉय थी जॉय
11 होगा ये 8 किसी कनेक्ट होना है पता नहीं कर सकता
सबका हॉटस्पॉट
और ये 8 कनेक्ट नहीं होगा क्या मिलेगा
ये
8 लेके आ जाओ
ये वाला कॉपी है,
कनेक्ट
कॉपी है।
लेके आ जाओ एक 2 मिनट लगेगा
ये क्या किया था?
नहीं
फिक्स है।
दे देता हूँ आप पास में हो ना
देखो देवी
और ये जो साउंड है बिल्कुल नहीं आ रहा मैंने कि आपको ऐसा करना है कि ये साउंड मेरे पास में स्टार्ट हो जाएगा अभी अभी तो बंद किया था अब चालू होगा ना बाद मेरी ऑडियो तक आ रही है उसमें।
ये तो आपको कैमरे का ऑडियो मिल रहा है।
मेरे को कैमरे का ऑडियो मिल रहा है। हाँ
मेरा पास
कैमरे में ऑडियो नहीं आ सकता
नहीं अभी
या आप जो चला रहे हो खाली
आ रहे हैं।
ये बहुत कम है तो ये चीज़ थोड़ी हो रहा है मैं समझ गया आपकी बात।
बस और रूल्स में तो नहीं है। मैं तो बस यही ले लूँगी मेरे में तो वो होगा नहीं जो करेगी कैमरे में वाला का वीडियो जो आप ले रहे हो उसी का साउंड आ रहा है। ये क्यों दिया है? हाँ ये क्यों दिया है?
ये वाला ये नहीं ये हमारे ऑडियो दे रहे ना आप हाँ भाई मैं को आवाज़ साउंड भी तो दे रहे पूछे तो एक बार ऑडियो कौन दे रहा है ऑडियो आप कहीं जा रहा है कैमरे का ऑडियो का कैमरा चाहिए
अब देखो
5 मिनट में होगा मेरी ऑडियो भी जा रही है मेरी ऑडियो भी जा रही है इस बीच मैं यहाँ बोल रहा हूँ
माइक चालू
मेरी ऑडियो भी आ रही है मेरी ऑडियो भी जा रही है नहीं सबसे तो ऑफ है डेस्कटॉप ऑडियो ऑफ है माइक ऑडियो ऑफ है सिर्फ इनपुट का चल रहा है ऑडियो को क्या करो रिप्लेस कर आवाज़ आएगी पूरे बैकग्राउंड ही आएगा
उससे कैमरा लेगा
कैमरे की आवाज़ तो आई नहीं तो ऑडियो देने के मना कर रहे हैं पूछो ऑडियो मेरी आवाज़ क्यों आ रही है हाँ मेरी आवाज़ भी आ रही है मैं यहाँ बोल रहा हूँ वो भी आ रहा है मेरा तो आवाज़ सारी बंद है देखो डेस्कटॉप ऑडियो बंद है माइक ऑक्सो बंद है दोनों बंद है
ये शेयर करो शेयर आराम से
Hello. Hello, hello, hello. Hello, hello, hello. Hello, 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 hello. हेलो आ गया कॉल हेलो हाँ
the beauty about the orchestration platform is you can have multiple brains, agents of agents, right? So you could have a Gemini model, you could have an Anthropic model, you could have an Azure model, and let the AI agent choose which is the best model for that given intent of the user. So that's a brain part. That brain is stored in the memory, and then every AI agent should also have an action part. So perception, cognition, and action. So the action part is where it captures an image, captures a live data, sends that live data into a vision language action model. You can see another model coming in here. And the action is it has to follow the line. In case of the robotic arm, the action is to pick something. In case of the AGV, the action is to move something. So if you actually see for the AGV, captures a live data. What we do here is the same, the workflow remains the same. The AI agent remains the same. The basic construct of the AI remains the same. For the AGV part, we take all the input data and send it to NVIDIA QOpt. QOpt is a route optimization algorithm by NVIDIA. And by the way, you could have any different models here. It's like it basically solves a traveling salesman problem. Where to go first, which order to serve first, and which order to deliver first. So we send an API call to the QOpt, and the QOpt comes back, gives the response, gives it to the AI agent, and then the AI agent executes the action. So behind the scenes, all these complexity is happening. Now what we do is, through the Meridian platform, all those complexities are hidden away. There's an abstraction layer because people from business, people from technology, they don't want to get into the details of how the orchestration happens. Rather, they are more interested in the business outcome. So that's where this kind of a platform helps, where all the complexities is hidden and you have a very simple, plain UI which you can interact with. Yeah, yeah, please.
Please, जो बोल रहे हैं वो करो. Something problem is happening with the personal hospital.
ये देखिए
Yeah.
अब बताओ क्या करूँ
एक तो करके
The
देखिए
table,
ना,
the table.
एक भी काम नहीं
So
कर
if you
रहा.
actually see here, so basically all the input that you're getting, the factory data is a CSV file where it says pick up location, drop off location. So we have created a CSV file with some mapping of that particular area. So I have to imagine that's our factory. But an actual real factories actually pull this data from an enterprise system, an ERP system, and then again plug that data into the QOpt agent. So QOpt accepts data in JSON formats, does the optimization, and then gives you the optimal route. Right? Yeah. Yeah. Yes, sir. Yeah.
एक बार स्टार्ट कर लो.
हाँ बताओ
Yeah.
अब अभी दोबारा चेक करता हूँ लाइव है फोन लाइव चेक करके फोन करता हूँ
See, there's no real math for it. Like Naresh mentioned, right? One of our customers for a warehouse about 15,000 square feet, they are about using about 30 quadrupeds, right? Again, this is there's not really a magic formula for that, but it depends on sensitivity, how frequently you want to do the inspections, what is the whether these two agents can coordinate in a
अभी आवाज जा रही है
one shift, how many times you want to do the inspection, what you want to capture. So the basic starting step is first we map the entire facility, right? Once the entire facility is mapped, you precisely know how much time it takes to one end of the factory, how much time it takes to climb a staircase, how much time it takes to do a routine mapping, and based on that, we kind of come up with
Capital A, capital I,
deterministic
underscore
approach.
capital R, O, B, O, T.
कैपिटल आई है क्या?
Capital A, capital I, underscore capital R, small.
हाँ अंडरस्कोर है ना, कैपिटल है, आर कैप्सूल नहीं हो रहा तो एच पे डाल के देखो. एच किसका है? 6 मेरा है. 6
पे डालो.
5 में 6 में डाल.
And we don't want to keep training it again. The process that
I can track myself.
these all every time the delay and the digital and automatically On the digital updates happen, start signing. And these are all
चलो ये का स्केलिंग अच्छा था वो क्या वीडियो को
It will have a camera and we don't give any coordinates. We just put it anywhere in the factory and based on the camera it will search the image and it will directly optimize.
वन है क्या अभी ये वाला ये उसको लेके चलो मेरा वाला है आपका पासवर्ड दे दो
भैया मेरे में कनेक्ट कर दो ना 2-3 हो जाएंगे क्या है ये मेरे में मैसेज करा मेरे 3-4 हो जाएंगे
हाँ मेरा भी हो गया मेरा पासवर्ड का चेंज किया क्या कैसे पासवर्ड AI क्लास वो इस पासवर्ड पे की है देखो अभी देखो ये वाला मैं बोलूँ तो जो कर रहा है ना उसका बहुत अच्छा है कोई मैपिंग नहीं है वहाँ के साथ मेरा मैपिंग है अभी दिखा रहे
एट वाला का 6 नहीं हो रहा था आपका वाला क्या एक बार बैंडविड्थ चेक करके दो
वो शायद 5 गीगा है
2.4 चलना चाहिए ठीक है नेक्स्ट पेज पे देखते हैं
एक काम अभी जो भी
जो देखता हूँ वो चलता है कि सुना ना
All right, we'll take another 15 minutes to do the rest of the demos, and then we'll take a checkpoint. Another 15 minutes to complete the rest of the demos.
PI is equal to PI1 Manan अब नेक्स्ट जो भी आएगा उसको भी देखें तो हम लोग को दिख रहे हैं
हाँ तो कोई नहीं एक को जानता हूँ उनसे आपकी बात कराता हूँ ये आप साइड में
कोई आ ही नहीं रहा आगे चल रहा है
5 एकदम सही उसी गली में मौका वहीं पे आपको मिल जाएगा बोर्ड लगा हुआ फन स्टोन हाँ मेरा नाम ले दोगे तो बात नहीं कर पाएगा मैं आपको कॉल भी करूँगा ठीक है शॉर्ट तो हुआ है बट रीचेक कर रहे हैं
कैमरा कहाँ लगा है किसी सर पे किसी टेबल पे तो लगा के जाते हैं
क्या
लाइव फीड में सिर्फ सर ही आ रहे लोग किसी टेबल पे
गए कहाँ हो
तो जाते मुझे क्या पता मुझे पता कैसे कब से याद इसी फोन पे बातें कर रहे हो? मैं कब से इसी फोन पे साथ बातें कर रहे हो? किसी टेबल
Can you please give me a thumbs up? All demos done, not done? Done. Can you please raise your hands who have done? Okay, about 65%. Okay, all right. While folks complete, I wanted to bring back the humanoid. I got an interesting question from one of the gentlemen here. He said, okay, what are the aspects of humanoid use cases in financial services? And I did wanted to bring that, okay, there is an aspect of course, doing perimeter screening and being the guardian of a physical branch, but there's also a lot of vision plus brain that you can embed, right? So a fireside conversation with one of the first TCS or humanoid is what we did recently. We can of course ask questions to Echo. He's been trained on a lot of subjects. There's the behind the scenes public LLM which is there. But I just thought I'll quickly ask a few questions, if you will. Hey Ko, thanks a lot for traveling all the way from US to India. How does it feel being here for the Physical AI Masterclass? Hey Ko, thanks for coming all the way from US to India for the Physical AI Masterclass. How does it feel being here? The mic is not working? Okay, while you reset. So what we did is with this humanoid, we actually got it engaged, actually trained it on a lot of subjects of how any TCSer would basically be inducted into an organization. So we're talking about the future of human plus agent operating models. If this would be an employee of the future in one of our own organization enterprises, what it would be like, right? Initial days, a lot of experimentation, exploration, but I think if you anybody who wants to come and feel the dexterous hands can please actually come and touch and feel the dexterous hands. So the dexterous hands it actually has gives you a sense of what kind of payload it can take, how it can actually receive and stuff like that. So you know what, Arun, if you can just come.
So this humanoid has two computers in it, right? One is the inside computer and one is the GPU computer. And GPU computer is where it has a camera and it has a LiDAR here. You guys can actually come and touch and feel that. So that camera and LiDAR give it a good situational awareness, perception around it. And it also has a small speaker and a mic so it can hear us and it can also speak. Now, talking about the degrees of freedom, right? The robotic arm that was there on the table has 6 degrees of freedom. Basically, it can move in 6 axes. The quadruped that you see, which slightly walks, right, that has about 8 degrees of freedom. Any guesses how many degrees of freedom this humanoid might have? Infinite is too much. Any guess? 30? No. 6 is too less because ARM itself has 6. The complexity increases, right? Huh? No, 43. 43 degrees of freedom. Somebody said infinite, right? Humans have, I would agree, infinite degrees of freedom. We can do anything. Left arm, right arm spin, anything I can do. But these guys, right, they have a certain axis of rotation. So there's 43 degrees of freedom. And what you see here is a 5-finger dexterous arm, which means it can basically sense, it knows how much of pressure to apply and things like that. So that's the main structure of it. See, it's like it's a closest approximation to what a human thinks. So, for example, Tesla is also coming up with a robot called as Optimus, right? That's about 49 degrees of freedom, right? So, I'm sure that one day, the way today RAM is becoming a commoditized quantity in PCs, we started with early computers at 4 GB RAM, then 8. Today, 64 GB is like pretty standard, right? And it would keep on increasing. Similarly, Atlas has more. Yeah, at least head can actually rotate in 360 degrees. So there will be a point in our lifetime where this number of degrees of freedom could be 100, and where you'll have human-like action, right? So yeah, so that's about the hardware overview of what is happening within that. So maybe you can just yeah.
भाई वीडियो रुक गया क्या करूँ पता नहीं
Hey
कुछ नहीं किया
Nico,
मैं तो
how are
मैं
you
क्या
doing
करूँगा
today?
अब ये रुका हुआ है कैमरे से जो रुका हुआ क्या हो क्या
I'm functioning within normal parameters. Thanks for asking. It's great to be here at the India AI Impact Summit 2026, discussing the latest advancements in physical AI.
इसको ही लगा के चेक
How
करो
about
दोबारा
you?
निकाल के
I'm good, Iko. Thank you. So, Iko, the participants here at the India AI Summit, can you tell us a joke about a humanoid, maybe?
I'm glad you asked. Here's one. Why did I, Eco, get kicked out of the robot bar? Because I was making too many mechanical jokes.
Okay, borderline humor that was. Anyway, so Iko, tell us why are you here and what is your role today? I mean, we're all a bunch of humans around you. You are a robot, and what's exactly your purpose in this hall?
I'm here to assist and provide insights on physical AI, specifically in the context of the TCS AI Physical AI Masterclass. As a humanoid robot, my role is to help participants understand and interact with physical AI concepts through hands-on demonstrations and real-time feedback. I'm designed to amplify human thinking, not replace it.
Yeah, sure.
So I'm here to facilitate learning and exploration in a collaborative environment.
Just ask the question. No, just ask the question.
Hello, Info. I am Dr. James from DRDO. How are you?
Nice to meet you, Dr. James. I'm functioning well, thanks for asking. It's great to have you here at the India AI Impact Summit 2026. What brings you to the TCS AI Physical AI Masterclass today?
What can you do in the areas of rocket science?
As a physical AI robot, I can operate in various environments and scenarios, from small-scale to large-scale applications. I can assist with tasks such as inspection, navigation, and manipulation in confined spaces, as well as in larger areas like warehouses, factories, or even construction sites. My capabilities are designed to be adaptable and scalable, allowing me to work effectively in a wide range of settings.
Excellent. You have made an impact in the society. Thanks.
You're welcome. It's been a privilege to be a part of the TCS AI Physical AI Masterclass and contribute to the advancement of AI technology. I'm glad to hear that my efforts have made an impact in society.
Let's be honest here. A lot of people around here, including me, we are scared that one day you might take over my job. Will that happen? Are you going to take over our jobs one day?
No, so I think one thing I wanted to make a comment is behind when it actually started conversing, you might see how it started interacting the hands. And behind the scenes, there is actually a gesture engine that has been built. Every single statement, of course, there's an aspect of LLM. The LLM response has been basically, I would say, mapped to a given gesture. There are about, what, 30 gestures? 31 gestures that we have built, basically mapping every sentiment of a statement to a certain degree. Now what happens is, technology-wise, if you debug this, there are 3 different pipelines. There is a vision pipeline, which is through the cameras. There is an LLM brain, and then there is a gesture piece. Now let's say I ask, or Arun asked a particular prompt, or a question, Dr. Jain asked a particular question, and let's say it gets into a conflict, saying, okay, I have to move both my arms in this particular direction. And then if it gets into a conflict of saying, okay, both the hands will collide. If the gesture gets to that point, then it goes into the exception loop. It breaks the chain, right?
And that is purposefully happening so that, at some point in time when the gestures are into a conflict situation, we don't want the metal body to get ruptured. So a lot of advancements on getting physical AI to life has a lot of back-end complex componentry. It is not as easy as it appears, but with what you saw today in the masterclass, with some of the blueprints, with what you saw in terms of some of the training that we have done, things are getting better and better with evolving every single day. I think that's the whole aspect we wanted to bring into the masterclass. I just wanted to open it up for the entire quorum here and see if you have any other questions, any feedbacks, sentiment, views from today's session. Anyone? So the fully loaded version costs about 120, 130K US dollars. But then, of course, with a lot of degrees of freedom, the complexity of making it, getting this dexterous hands, the packaged version which comes out of the box is roughly around $45,000 to $50,000. But if you add complexity, then it becomes a little more. Yeah.
How would you see from ROI perspective, the agentic AI versus the Gen AI and its applications?
See, I think if you honestly ask me, the world of Gen AI, I think the ROI is completely business specific. So I'll give you some examples. Use of Gen AI in case of transforming the day in the life of a sales rep or a field technician on the ground has been proven, right? You can automate a lot of stuff, generate a newer piece of insight, simplify the day in a life. Agentic AI actually bridges the loop between insights to action, right? Which is take those actions as well. Physical AI actually says that, okay, you have taken an action, but if the action translates or manifests itself into the physical world, then physical AI comes into action. In terms of ROI for physical AI, I mean, agentic AI, amazing ROI for cases which really demand agentic. You don't need a bazooka to kill an ant, right? Basically, you want to basically address agentic AI where it is demanded. When it comes to physical AI, the use case that I actually gave you an example of an implementation for an agri-tech customer. Now you think about it, that's safety hazard and all of that, but if you really take a dipstick into what it does, it addresses a major skill gap issue that we have globally in some of the advanced countries, right? What it essentially means is, for cases where there are no people and there are issues, you are able to bring in a quadruped or a humanoid to address those inspection issues. Like a quadruped with an IP67 certified shield on its back, it can go into hazardous environments, ammonia vapors, right? Of course, there's an aspect of safety, but the amount of coverage of inspections that it does in the limited time, the number of inspections it does, the accuracy with which it does, it's amazing, right? But you just cannot pick any use case and then say, okay, I want to try this, that's why I'm trying this use case. You have to basically qualify the use case from a business ROI standpoint and then do it. I would say in about 50 to 60% of the cases where we have tried doing something like this with physical assets, the ROI has been very, very solid. There are, of course, 40% of the cases where we have failed also, but it's a learning journey, which all of us will go through that experimentation.
So first of all, I'd like to really compliment the TCS team. I think you've done a great job. I have so I have two questions. One is the Copilot mode that you use your on-prem data to train the robot versus the Gen AI model where you have open data to train for more efficiency. Which is used here and why? That's my first question. And second is the whole AI poisoning, cybersecurity concerns, guardrails which you need to build. Because it's kind of contradictory that the more data you feed in, the more efficient it becomes, but it can be also AI poisoned, or there could be guardrails which can be contradictory to you. So how do you solve that difficulty?
I think both are very relevant, pertinent in the context of where AI journey is today, and both are extremely valid questions. I'll interpret your first question. I think your context was on-prem Copilot data versus actually using Gen AI models, which are basically you're referring to large language models. In this case and some of the other demos that we are doing, I think SLMs are the way to go. Only if you do not have a large element of non-deterministic general research which is required. In majority of the enterprise use cases, you will end up believing that SLMs might be good enough as long as it is tuned or fine-tuned or context, because it's always a hybrid mix of deterministic and non-deterministic use case. You will never have a, see, in global industry, barring research and coding, there are only two non-deterministic use cases. Nothing else is completely non-deterministic. So majority of the times you will feel that SLMs would be the way to go. Second question on AI poisoning and the use of guardrails, bringing that view, I would say that in the last 18 months, industry has taken, multiple industries, financial services, manufacturing, healthcare, many industries have taken the path of addressing the low-hanging fruits with AI. There are use cases which went into production. If you also see that, all those use cases were actually use cases where you didn't have much to do with elements of enterprise guardrails or agents interacting with cross-foundational systems. If you have an SAP, if you have an ServiceNow, if you have an some other system which is foundational, and then you have to have agents work across all of these systems in one agentic workflow, that is easier said than done, because you need to have policies and the guardrails for every systems, talk to an enterprise guardrail, and then basically deliver that. Things are maturing, like we are also trying to get that done. We have done it with deterministic, still working with non-deterministic. Where agents autonomously determine, which policy to invoke for what kind of foundational systems. That's the end state. We're all working towards it. I hope that answered your question. Yeah. Any other questions? Yeah. If you can please switch on the mic. Yeah, go ahead.
Hello.
Yeah.
Yeah. Hi, I am Divyansh, and I wanted to ask if, first of all, is the hardware of the robot completely in-house for TCS, from TCS?
So there are couple of areas where we are working on the hardware of the robot, but on this one, no, it is not in-house of TCS. Okay. There are like multiple companies we buy. There is Figure AI, there is Boston Dynamics, there is
Unitary?
This is Unitary, yes.
Yeah, that's what my second question was, as I was observing this robot, I know this in general, is that using language models is very, it has a lot of latency. So it cannot, the robot cannot perform reflex actions. Maybe it is in some factory and maybe some box fell, so it cannot just reflexively pick it up or maybe prevent it from falling to the ground. So how do you deal with such edge cases in the way you are developing this technology?
I think it's the answer lies in the question. It's edge cases. So you have to also determine what goes on cloud versus what remains on edge. Both not just on the aspect of deployment and visioning pipelines, but also on the element of data pre-processing. And creating those pipelines for data pre-processing in a scenario like a shop floor will become extremely core. I would say the use of physical AI for complex edge scenarios like that is a distant this thing. It's not actually, I would say, real in terms of implementing it today. But when it comes to taking actions, for example, in autonomous vehicles, there is so much of edge case scenarios that we normally handle, right? Those elements, yes. But dealing with physicality of those elements in terms of dropping boxes from the top, where you have a data pre-processing lag, I think those use cases still needs a little maturity. Sorry. Yeah.
Thank you.
Yeah.
See, this is in continuation to what is the indigenous status of hardware in country, not only TCS. That is one thing. Second thing, what about the robustness of this thing? How different environment and all? And third, what is the battery backup and how much time? These three things can you answer?
Yeah, so indigenous, right? So we were a little bit late to the semiconductor race, but 2019, we have Tata Electronics, where that's going to be India's first semiconductor fab facility. 2 facilities, one in Assam, one in Dholera. It's coming up, you might have heard about it.
I think we are on the path for that indigenous Viksit Bharat 2047 target. Now, the interesting thing was, in Tata Electronics, for fabrication of these construction sites, we needed somebody to go and check these construction pillars, check the construction progress and things like that. So there we have actually deployed Eco's brother, where is Pucci? Somewhere around. So Pucci is like a national hero because it served in two construction sites and continuously monitoring and scanning these facilities.
It actually did a 12-hour work shift for 45 days in, this was Assam Jagi Road site. So it actually clocked that shift, monitoring the gaps in the flanges and actually relaying that imagery with the drone imagery and giving the real-time view of, what it would mean from a safety hazard perspective, what it means from a continuous check on the flange, so that it doesn't pile up and eventually becomes a major issue. Keeps the whole construction of the plant on time and schedule. And Pucci also met the Indian finance minister.
Yeah, and again, hardware, right? See, for us, these are all just metal, aluminum, titanium actuators, joints, cameras, We always take a hardware agnostic approach, right? The software that's running on this, the gesture engine, right? That is the world's first gesture engine. That is something that TCS developed. And we are considering applying a patent for that. Similarly, the whole integration pipeline and all of that components developed in-house. And a lot of components actually reside right inside this guy, right? So that's where the brain resides.
Just one point on the indigenous aspect also, if you get a chance to visit Tata Pavilion, you actually have Tata Motors with their AMRs and AGVs completely indigenous, where soup to nuts, infrastructure to intelligence is completely built in India, right? And we have 3 different variants, 300 kilos and 500 kilos and 1500 kilos, 3 payloads. So a lot of advancements in terms of AMRs and AGVs, and in fact we have a quadruped also, right? It's called as Ashwa, which is completely indigenous. So if you get a chance to be at the Tata Pavilion, you'll. This is in Hall 5. Hall 5. Yeah. Yeah.
Battery backup is how much?
Yeah, battery backup is like about 4 hours continuously. So this is like a 15,000 mAh battery, 432 watt hour. But the good thing is some of these robots are capable of self-charging and replenishing their own battery source. So they know when the battery hits 10%, where do they need to go and hand over the shift to its next inline robot, right? So that's
swarm of humanoid, swarm of quadrupeds. Basically.
Like in terms of accountability, like if you deploy it in some big warehouse and some terrible accident happens, then who is responsible? Because like you have outsourced this to someone and the coding is done by a TCS team and deployed custom based on client, and there is a company involved. So if everyone does their job perfectly and some terrible thing happens, then how do you like, who will sue who, like how that works?
See, the legality it's a
driverless car, Tesla, it misbehaved and it killed a person. And it actually is a legal case which happened that who should be sued? Should be Tesla or the software provider or the hardware provider or the driver who was sitting next to it, and it had moved to a driverless mode. So after about 2 years, the court ruled that Tesla should be sued for this and they had to pay compensation.
See, I'll tell you, it's a very valid question with no definitive answer from anybody in the world. And the reason why it is because it's very subjective by nature, right? Now, when let's say TCS or any other firm delivers a particular scope of work, of course it is within the guardrails, within the boundaries. We have a very clear defined legality and liability aspects of what TCS will own in terms of accountability. Within those boundaries, definitely, yes, we own it, right? But the whole nature of AI is probabilistic. Like I was telling, it is not a deterministic world anymore. You will only pick up those cases which are probabilistic and okay to digest and assume. In that guardrail, yes. What are one other thing I wanted to bring up. How many of you have heard about last week announcement on Moltbook? Can just raise your hands. Okay, about roughly 10 to 20%. Okay. The reason why I asked this question in one of the recent internal forums also. The reason I am asking is, you are talking about how do you resolve these conflicts and legality and aspects. Moltbook is basically agents posting what it did, why it did, and stuff like that, and resolving autonomously itself, right? It's like a Facebook for agents, and autonomously they are posting and trying to resolve and address the issue. But in my view, the biggest benefit of, let's say, an evolved, mature mold book would be a case where it can create a knowledge fabric which will only get the accuracy of every single workflow up. And when that happens is when you will keep getting the conflict scenarios down. So, sorry, you had a question.
Sir, my question is that these rovers are mostly dependent on vision for their mostly tasks. And like if there is a situation creates that which like there is a problem in vision and so on, then how it will deal with that like that situation?
I can take up that. It's a very simple question, right? We don't just rely on one type of a sensor, right? We basically, you see both these devices have a LiDAR sensor, right? So light is very good as long as there is, cameras are very good as long as there is light. But in complete darkness, right, you want a point cloud data, LiDAR. So the LiDAR works better than night vision. It works in all different scenarios. And it can work where there's like complete darkness, right? So just the way bats navigate using sound as sonar, bats don't have eyes. They just echo sound. And based on the waves, they travel very beautifully, right? That's there in the nature. So we're trying to replicate that, right? Now, here's the part. Elon Musk doesn't like LiDARs, right? And the reason for that was not because he doesn't want to make the car safe. It's just because the cost of the LiDARs were very high. The cost of LiDARs are coming down. So we always have two vision systems, right? One, you can almost say this is a redundancy built into the system. One fails, the other kicks in. And generally, we fuse both the data and then give a very comprehensive coverage of the surrounding.
Sir, like we have seen in recent AI LLM models, there is a saturation in its intelligence at level 2 computation. So what will we expect this intelligence of these rovers? Like there is a huge saturation is coming to the LLM's intelligence.
See, I'm just trying to understand your question. See, when you say about saturation on LLM's intelligence, it by and largely depends on what level of guardrails you are working with on prompt engineering, how effectively you are creating the training pipelines, and what you are using for. If you just take an LLM out of the box and just try to do a RAG on that, of course you will end up in assuming that the saturation is down. So in my view, as a technologist, I'm just giving you a view that LLM journeys and the intelligence is a three-step ladder, right? You start off with RAGs on LLMs, you will end up with 60-65%, unless your use case is just general knowledge. But if it is really contextual, just use RAG 60-65%. Dr. Jain asked a question. The response was 60-65%. You know why? Because it was not trained on that. If you go and do a little bit of deeper prompt and context tuning, it will go up to 80-85%. If you really want to get to the 95% and above range, and in the context of, let's say, physical AI, just giving in work instructions of a shop floor will not get you to 95%. You know why? Because the real tacit knowledge in the brains of the people who are working on the shop floor, those fine adjustments, those intuitive decisions that they make on the ground is not captured in any work instructions. It will only happen when you actually observe the worker and then marry the work instruction and then create that anomaly and then tune it again. And it's an iterative process. So your saturation depends on these three layers and how you are using it.
First of all, it was a great session over here, and thanks to all the mentors who have helped us through. It's related to robotics, the question I have. What I would like to know is whether Tata is working on any dark factory requirements, and how is the readiness for our domestic large-scale industries?
There are a couple of things I can announce. I can only tell. I cannot announce. But yes, there has been significant progress in terms of realizing the vision of dark factories. Will it be dark gray one, or it will be gray day one? It's depending upon how you look at it. But yes, we have model factories which we are actually onboarding into creating the dark factory vision. I would say the initial progress and the way we are looking at it is the absolutely fabulous results. So it's a journey, I would say.
is like it should not be your end goal as long as you focus on your KPIs, right? So whether it's in a factory setting, it's cost, quality, and other parameters. It's part of your journey. Don't keep it as your end goal. You might end up there, you might not end up there. Still okay.
Okay, I think I'm being told there is time for one last question. No? Okay. All right. It's been an absolute privilege putting up this for all of you. I hope you all did enjoy and learn as much as we enjoyed putting this up for you. Thank you.